Hey everyone, and welcome to a new video on this channel. This time about Canary deployments with Argo Rollouts. Now, there's another video on my channel which is about blue-green deployments with Argo Rollouts, and it's really recommended that you look at that video first, as I won't repeat some of the terminology and use cases for the software. So basically, let's look at, from a theoretical point of view, what a Canary deployment is, and then let's try to do it in practice. Yeah. Now, when we do a Canary deployment with rollouts, you will have to create a rollout manifest. Again, that was explained in the previous video as well. That rollout manifest is very similar to a deployment manifest, in the sense that it will actually use a replica set underneath. It will use the replica set to make sure you have the amount of pods running for your application. And I will use an example application that's a simple WebSocket or a socket.io service. Then you'll need, of course, a Kubernetes service in front of those pods. And we call this the stable service. In this case, you see a stable service, and the endpoints are the 5 pods in that replica set. And in the example I'm going to show you, there's also an ingress. The ingress controller is Nginx ingress, which is, by the way, well supported by Argo Rollouts, as you'll see later. And this ingress controller is making the application available to the outside world, right? That's the first step. When you do this rollout, very similar to a deployment, you get this kind of system. But of course, in the rollout, you will define the way how to handle updates to your application. So if your developer has created a new version of the software and you want to transition to this new version, well, then in the rollout manifest, as you'll see in a moment, you need to define some Canary related properties. So when you select Canary, and you do an update to your application by changing the spec in your rollout manifest, what will happen is that a second replica set will be created, and this will be used for the Canary. And for example, in this case, if you have set the Canary deployment to 20%, which means that 20% of the traffic will go to the new version of your service, 80% of your traffic will go to the old version of the service, then something similar to what you see here will happen. And so rollouts will scale down the first replica set to, in this case, 4 pods. 80% of the pods are handled or still in the stable service, and 1 pod, 20%, will be in what we call the Canary service, and that you also have to create upfront, but rollouts will manipulate the endpoints in these services for you. That does, of course, mean that people who go to your service in this case will see, let's say for a part the old one and use for another part the new one. And you, of course, will have to see, are there any issues with people connecting to the new one? If there are issues, of course, you will do a rollback. If there are no issues, you can progress to let more and more people connect to the Canary service. For instance, you could have multiple steps in your rollouts and have, for example, a second step, you go to 40%, a third step, you go to 60%, and then you decide to switch over completely, for instance. So what you see here is maybe one step in this Canary release, but there might be multiple steps. And you'll see in a moment in the example that I'm using multiple steps. It will all become more clear. At a certain point in time, you have to decide, my Canary release will become the stable release. What happens then is, by way of automatic promotion or manual promotion, your existing replica set will be scaled to 0, and your Canary replica set will, of course, become the, let's say, the green pods now, or the stable service. And that also means that the stable service will be pointed to the new version of your pods, which are hopefully now properly working. By the way, the old service or the new Canary service will also point there. And your ingress is always pointing to the stable service. So in this case, everything will go to stable. You will have stable pods active, ready for your next deployment. Now, that's all fine in theory. Maybe it was clear, maybe not, but hopefully with the example we're going to give, it will become clear. So I have a cluster running already. The cluster has normally everything configured for us to get started. Just like in the previous video, you have to of course install Argo Rollouts. That is very simple. You see here a kubectl create namespace Argo Rollouts. Then you apply a manifest. If you have version 1.16 or less than that version of Kubernetes, you're gonna use the -- validate is false option. Now, I already created a manifest that has the correct settings or the sample settings I want to show you today. So just like yesterday, you can convert a regular deployment into a rollout. So this was a deployment before, it had other things here and it had kind deployment that was changed into a rollout. In this case, just like in the slide, I'm going to use 5 replicas of my service, and my service will be version 1.0.0, right? And I will later upgrade this to a new version. This is all the same as a deployment. There's nothing different there. So you have your spec, you define your containers, you set memory limits, you give environment variables. That doesn't really matter. It's the same as a deployment. But then you have Canary. The strategy is part of this of what a rollout supports. And I'm saying here, okay, my strategy to update is Canary. You have to have a stable service and also a Canary service. Yeah, stable service and Canary service. That's just services in the beginning defined that go to your app based on the selector that you have chosen. So in my case, selector app real-time. So I have this real-time app active. Should actually have called it stable. You know what? I will do that. I will modify this into stable, and I will set the other one, which is very, very, very similar. I will set that one to Canary, right? And then I will modify this here. The stable service is real-time app stable, and the Canary service will be real-time app Canary, right? Now, what you see next is optional, but of course is recommended. That is setting traffic routing explicitly, percentage basically. And then of course you need to have something in place. You have to have something running in your cluster that can do the appropriate traffic routing for you. If you don't use traffic routing, the system will just approximate the percentages you want to go, the percentage of traffic you want to go to Canary by playing a bit with the number of pods in the stable service and the number of pods in the Canary service. So for instance, if I'm not using traffic routing with Nginx, but I'm saying 20% of traffic of my 5 pods has to go to the Canary service, he will make it 4 to 1. If you want to be exact, right? If you want to be exact, then you should actually use traffic routing, which is a bit more refined and a bit more, let's say, a bit more exact. So for traffic routing, we're using Nginx. Nginx is a supported means of doing traffic routing because Nginx in its ingress definitions also supports Canary annotations, and that's what is used behind the scenes. So traffic routing is Nginx. We are pointing to the ingress. We call that the stable ingress in this case. Stable ingress is, in this case, my real-time app ingress. That's the one you see here at the bottom. There's an ingress defined, and that ingress defined goes to, actually good that I go there, goes to my stable service, which it always has to do. So I'm going to modify that. Good that I caught that error. By the way, we're deploying here an app with a DNS name as well, so it will be realtime.baco.info. We'll see later that we can go there, right? Good. So that's our traffic routing. We say use Nginx to do the routing between the Canary and between the stable service. Then I talked a moment ago about steps. Now, The steps I'm using here are quite naive, and maybe in another video we'll look at some, let's say, more intelligent ways to set these steps and to also verify if we should proceed or not. So in this case, what I'm doing here is just an example, right? So the steps in the Canary release are the following. The first step, we set the weight to 20%, right? And then we pause for a duration of 1 minute. Just pause. After that minute has passed, we set the weight to 60%. I just took an arbitrary value here, 60%. And then we pause indefinitely. And when we don't give, for example, a duration, we pause indefinitely. That also means that we have to promote our Canary service or Canary manually to be the stable one. In reality, or in a production scenario, we would do this differently using, for example, metrics to decide if you're going to switch over or not. But that's for another video. I'm not going to mix it up and make it more complicated at this point in time. So let's save this and let's deploy this service. So I'm in the right folder, kubectl apply -f, and then real-time YAML. Now I didn't, let's say, prepare 100% for this. So when there are errors coming up, that's fine. We'll try to fix them in real time and see how far we get. So I'm applying this, and of course the resources are created. And let's take a look, because there's an important aspect here. We want to see, so with kubectl get certs, we want to make sure our certificate is provided or is automatically provided on our ingress, right? So I have configured Nginx together with Cert Manager, and Cert Manager will automatically use, in this case, the Let's Encrypt production issuer to issue a certificate in real time. By the way, the realtime.bake.info DNS is also provisioned and updated with the IP of the ingress controller automatically due to integration with external DNS. So we give that some time to stabilize, and we'll in the meantime check out already what our rollout looks like. So kubectl Argo Rollouts. It's a plugin for kubectl that I talked about yesterday, or in a previous video as well. I made that one yesterday, indeed. So kubectl Argo Rollouts, I think it's list rollouts or list rollout. You see there, indeed, we have an app, the real-time app, Canary strategy, and it's healthy. 5 pods have been deployed. If I'm getting the rollout, so get rollout real-time app, I think that's right. Yeah, then you see the details here. So we have a healthy rollout, but of course it's the first rollout. That means the following thing: we are now here, right? So we have the rollout, the replica set, the 5 pods, the stable service is pointing to it, and the ingress is, let's say, busy now configuring itself with certificate and so on to get that right. So I first want to make sure that that is correct, and he's still busy with it. Let's give it some time, and we'll see how far we get there. Now that's not too important at this point in time, because we can already do a modification here by changing the image version. So your developer came to you and says, well, actually I'd like to go to version 1.0.2, and of course you would have a CI process and some kind of process in place that then would modify this automatically. Maybe you're using GitOps for this or something else, doesn't matter. I'm just doing a manual change here, and a simple kubectl apply of this manifest should be enough to trigger the update using the Canary method. So when I'm doing that, I'm doing kubectl apply -f real-time YAML. you see that he's modifying the rollout. The rollout is configured. And then let's check, maybe first check if the certificate is okay already. Yeah, it's okay, that's great. What happens now is that the Canary release, if we compare it, you see that he now does the following. He says, well, we are now in this state, but watch out, in that first minute, so for 20 seconds here, for a minute it will run like this, because I said step 1, 20% of the traffic should go to the Canary, but actually only wait for a minute. But what you see is here we have a couple of pods here now. We have one pod over here, and there is a let's say the step 20 was being set. Now the actual weight is 16 because it didn't remove all the pods here, so it's close to 20, but it's not exactly 20. Now if we keep on refreshing this, the steps will continue. So if I refresh this, 61% we're seeing here. Let's see what happens if he's modifying this. And indeed, and the 60%, the 60 seconds have passed. Step 2 is now happening. That's not a new replica set. That's the same replica set. But now we're saying, well, we actually want 60% of the traffic to go to that location. So to the Canary. So indeed, what he's doing now, there's some internal logic here that says, I'm gonna have a couple of pods more that can handle 60% of the traffic. For some reason, he's not modifying the number of pods in the healthy service. He stays the same. So it's not really 60% here. The actual weight is 37 when you look at it like this. But when the requests come in through the ingress controller, that will be nicely or more nicely divided and will be more or less around this 60% if I'm not mistaken. Now let's take a look if we can go to this application. So let's go to realtime.baker.info. What we see is this is version 1.0, and if we refresh this, oh yeah, indeed, this is now the 60% of the time we will go to the Canary service. Yeah? But for something like a UI, you wouldn't want to do this. But just to make things clear here, that you see that we're sometimes ending up at the Canary and sometimes ending up at the stable service. I'm just going to refresh this here a couple of times, and we'll see what actually happens. So here you see again, yes, we hit the stable service right now. Yeah. So not that in real life this is a good example to use Canary for, right? Although you could, some people that some users are getting this, but yeah, when they are refreshing their page, they would also see sometimes the other one. So that's not really what I would do in production. But you see the idea here. Eh? He's doing this this traffic. Yeah, splitting it is not, but this traffic 60% going to the Canary and 40% going to the stable service. Then I'm thinking, yeah, okay, we are now in the state here, this state, although with different percentages. I've seen enough. I think my Canary is actually great or good enough for me to promote. Again, there's a way to do this automatically. We'll look at that in other videos. But in this case, you want to just promote the release. So I'm gonna say Argo Argo Rollouts promote, and I think it's just promote a real-time app, nothing more than that. Yeah, that's now promoted. And what happens when you're promoting? When you're promoting is actually saying, well, okay, then we'll make sure 100% of traffic will go to what was previously the Canary service, and the old replica set will be scaled to 0. That has happened now. The old replica set is scaled to 0, and I have my 5 pods running. 100% of traffic is going to my 5 pods here, and it's healthy. What does that mean? That means, of course, that if we are checking out our service, and that's not really a scientific measurement, but if we're doing a refresh, we keep on refreshing, yeah, we will keep on getting this really silly purple background here, because we have progressed far enough. We have actually said Canary should be promoted to being the stable version, and it's done this way, right? So that's basically how Canary works. Now, want to give you a little bit more insight into what's behind the scenes when it comes to the ingresses, because that might be something that surprises you. You might think he's modifying the existing ingress or whatnot. No, he's not actually doing that. So you had your original ingress, the original ingress for, in this case, realtime.baker.info, including the TLS settings and certificate settings, but also including several annotations, like for example, I'd like to use affinity mode persistent, I'd like to use the cookie persistence, I also would like to use the Let's Encrypt issuer here. He leaves that intact. There's nothing changing here. You can see that this one is going to real-time app stable, right? Now, if you check this one was created by the rollouts software. So when Canary was being used, an ingress was created. This ingress is going to the same backend, but the service is Canary. And he actually said here, well, for this one, we set the weight. Now, for some reason, I think that I made, and now it's 0, of course, because everything has to go to that one. That would have been different in the in between steps. So now it's 0. So these two are actually combined. So these two ingress definitions are actually combined, so that yeah, they work together and make sure that a percentage of the traffic is going to the stable service and the percentage of the traffic is going to the Canary service, which in this case is now 0. Nothing is going to the Canary service because we have the stable one in release. So that's happening behind the scenes. In the case where you of course are using, as you have seen here in the definition, when you are using the traffic routing method for Nginx, and he knows what ingress he actually needs to use as a stable ingress and how to then create another ingress that is doing all the Canary redirection as well. Yeah. So behind the scenes, of course, the Nginx has to do some work here. So now we've ended up at this situation. Great. Canary release worked. Good to see. And of course, we compare this to the blue-green release. It's a little bit more complicated. And in another video, we'll actually take a look at how to configure these Canary releases by also looking at some metrics and then using these metrics to progress through the steps and potentially automatically release the new Canary if the metrics are saying that everything is fine and dandy. That's for another time. Thanks for watching and see you then. Bye bye.